Where do I run into organic chemicals in my life?
The food you eat, the clothes you wear, the gasoline in your car, the plastic bags you may, or may not get at the grocery store. The list could go on forever.
So, to restate the question, why do plants reflect any light at all?
The easiest answer here is that absorbing red and blue energy obviously works well enough. So evolution stuck with it. Evolution, after all, doesn't provide the best solution, but rather a solution. Nonetheless, let's make some guesses as to why plants are green. Chlorophyll isn't just after energy in general, but needs very specific wavelengths to pass along energy to the reactive centers of photosystems I and II. The second reasonable guess is that too much energy is not a good thing. Absorption of light creates high-energy species. And if they aren't used in some productive way, the energy will find something else to do. These other reactions could be destructive to cells. In sum, chlorophyll only takes what it needs or what it can use.
What makes strong acids and bases dangerous to work with in the laboratory?
Strong acids, like nitric acid, are strong oxidizing agents and can cause severe burns on your skin. Strong bases, like sodium hydroxide, can also cause burns as well as nerve damage. Strong acids and bases destroy your cells by reacting with the membranes, proteins, and other components that make up your cells. They are also dangerous to your eyes and can permanently damage your vision.
How is hydrogen produced for use as a fuel?
Most of the current hydrogen production in the U.S. is carried out by steam reforming natural gas, methane, which involves reacting steam with methane to generate H2, to make hydrogen a viable fuel source. More efficient ways of producing hydrogen on the large scale will be needed. Many scientists are currently investigating chemical and biological catalysts capable of carrying out a process called water splitting, which is the production of H2 and O2 from water, H2O. Water splitting may have the potential to make hydrogen into a viable fuel source for vehicles.
How many stars are in our galaxy?
Astronomers currently believe that our galaxy, the Milky Way, contains between 200 billion and 400 billion stars.
What is a nucleus?
The center of an atom, consisting of positively charged protons and neutral neutrons.
What is a monodentate?
A ligand that coordinates to a central atom via only one atom, compare with chelate.
How do nuclei spontaneously decay?
Nuclei can undergo several types of decay through spontaneous means without colliding or interacting with nuclei of other atoms. The most common types of nuclear decay are called alpha radiation, beta radiation, and gamma radiation. These differ by the type of fragmentation the nucleus undergoes during the decay process.
What is the main group elements?
Elements of the S and P blocks in the periodic table.
How does a pregnancy test work?
A pregnancy test works by detecting a hormone called human chorionic gonadotropin, HCG, that is produced in the placenta after fertilization. The HCG hormone will be present in the blood and urine about a week after conception. And it's detected by an indicator molecule on the pregnancy test that changes color upon binding to HCG. The tests you can buy in the store are actually pretty similar to those used at a doctor's office. Both are based on HCG binding to a chemical indicator that changes color. The main difference is that the doctor's office has technicians who are more familiar with using the tests. So there's less chance of a mistake with using or interpreting the test.
Why did Osamu Shimomura, Japan, Martin Chalfie, United States, and Roger Y. Tsien, United States, win the Nobel Prize for Chemistry?
For the discovery and development of the green fluorescent protein, GFP. These three scientists received the prize for their work with a protein simply called green fluorescent protein, or GFP. This protein was first observed way back in 1962 in a jellyfish. It eventually became a very important molecule in the biological sciences, as clever researchers have found ways to use GFP to study otherwise invisible chemical processes. Shimomura, Chalfie, and Tsien were at the forefront of the major discoveries that led to the understanding of GFP that researchers possess today.
What is an extensive property?
A property that depends on the amount of a substance present, e. g. Size, mass, volume.
Why did Francis William Aston, United Kingdom, win the Nobel Prize for Chemistry?
For his discovery, by means of his mass spectrograph, of isotopes in a large number of non-radioactive elements. And for his enunciation of the whole number rule. Following the prize in 1921 for Soddy, the Nobel Committee again recognized the importance of isotopes by selecting Aston for the prize. Aston built the first instrument capable of separating individual isotopes of a given element, which he used to identify over 200 elemental isotopes. This work led him to conclude that all isotopes of all elements have whole number masses. If one defines the major isotope of oxygen to be 16,
does hairspray contain polymers?
Yep, and almost the same ones that make white glue and acrylic paints. Many hairsprays contain vinyl acetate, or something similar. Polyvinyl pyrrolidone and / or lots of other variants. Like glue, you also need a liquid to disperse or dissolve the polymers. But in hairspray a mixture of alcohol and water is normally used.
How are the quantities on food nutrition labels determined?
The calorie content of food can be determined using a simple calorimetry experiment. The food just needs to be placed inside a calorimeter and burned to determine its calorie content. These days, however, the calorie content of a food can also be determined by simply using standard values of calories in each gram of protein. 4 calories/gram, fat, 9 calories/gram, and carbohydrates, 4 calories/gram. The trick is just to accurately determine the quantities of protein, fat, and carbohydrates in the food, and that's where analytical chemistry comes in particularly handy. The basic idea is that the fat, protein, or carbohydrates need to be extracted from the food. This can be done by choosing an appropriate solvent in which the fat/protein/carbohydrates are soluble, and then using spectrophotometry, or one of a variety of other methods, to determine the content of each species in a solution.
What is a watt?
A watt is the standard SI unit of power, representing 1 joule of energy per second. It is named after a Scottish engineer by the name of James Watt. To give an idea of how much energy this is, light bulbs in your house typically use about 25 to 100 watts. New types of light bulbs are doing a bit better than this, actually. For comparison, if you are doing manual labor over the course of a long day. Your body will average somewhere in the range of 75 watts of power output.
What is electrical resistance?
Electrical resistance describes how a material opposes an electric current through the material. The resistance is related to the applied voltage through the relationship R equals V/I, where V is the applied voltage and I is the current through the material. Typically the resistance is a constant, and thus the current will increase linearly with an increase in the applied voltage. This relationship is Ohm's law. As you can see, a material with a higher resistance, R, will have a lower current, I, for a given applied voltage, V.
What is electrochemistry and how was it discovered?
Modern electrochemistry studies reactions that take place at the interface of an electronic conductor and a source of charged ions, possibly a liquid. The development of electrochemistry began with studies on magnetism, electric charge, and conductivity. The earliest experiments typically focused on questions surrounding properties of materials. For example, which materials can be magnetized and which materials can be charged. As early as the 1750s, scientists had discovered that electrical signals were important to human life and were using them to treat medical issues such as muscle spasms. In the late 1700s, Charles Coulomb developed laws describing the interactions of charged bodies, which are still used widely today and taught in any introductory course on electricity and magnetism. The first electrochemical cells were developed during the 1800s. Electrochemical cells are arrangements of electrodes and sources of ions that either generate electric current from a chemical reaction, or alternatively, use electricity to drive a chemical reaction. Today these cells find applications in daily life, such as in the batteries that power your car or cell phone. Today electrochemistry still constitutes an important field of research and is one that will likely continue to lead to the development of new products and technologies.
What is an example of an alternative green reagent?
In a similar spirit to alternative solvents, alternative reagents are relatively environmentally benign reagents that are used to replace more toxic ones. One example of an alternative green reagent is dimethyl carbonate, which can be used to effect methylation and carbonylation reactions. Traditionally phosgene or methyl iodide have been used to carry out this same reaction. But the drawback is that these reagents are significantly more toxic and are thus also more costly to dispose of properly. Dimethyl carbonate is a non-toxic compound and it can be readily produced via an oxidative reaction of methanol with oxygen. thus avoiding any environmentally hazardous synthetic procedures.
What are diastereomers?
This is going to sound like a cop-out, but diastereomers are stereoisomers that are not enantiomers. That's the real, technical definition. One type of diastereomers show up when carbon forms a double bond. Recall from previous chapters that when there are three groups bonded to a carbon atom, it will be planar, sp2 hybridized. If the double bond is in the middle of a carbon chain, there are two possible isomers. These two molecules are not superimposable. But they're also not mirror images, so they are called diastereomers. There are many other forms of diastereoisomers, but this form is the easiest to understand.
What is styrofoam, R?
Styrofoam, R, is a brand name, owned by the Dow Chemical Company, for expanded polystyrene foam. It's 98% air, which is why those styrofoam, R, coffee cups are so light, and actually buoyant. In addition to disposable food containers, polystyrene foam is used in building and pipe insulation. Packing peanuts, and that green stuff they use for holding together fake flower arrangements.
How were herbal medicines discovered?
If we had the story of how each and every medicinal herb was discovered, each would likely be an interesting and unique tale. Unfortunately, the use of plants as medicine predates written human history by a few millennia. The earliest written records come from the great ancient civilizations of humankind.
Why do farts stink?
Farts are mostly nitrogen, N2, but that's an odorless gas. The smelly molecules in farts are mostly sulfur-containing compounds that reek like rotten eggs. Other odoriferous compounds include scatol and indole.
What is a noble gas core?
Used to abbreviate an atom's electron configuration, E. G. The electron configuration of nitrogen is 1s22s22p3, which can be abbreviated He2s22p3.
What is a ground state?
Lowest energy state for an atom or molecule.
What is enthalpy?
Enthalpy is a measure of the energy that something contains. And it's defined as the total heat content of a system. In terms of chemical reactions, we are most often interested in the change in enthalpy, denoted H, associated with the reaction. The H for a reaction is defined as the enthalpy of the products minus the enthalpy of the reactants. And this is typically measured via changes in temperature that take place during the reaction.
How does a nuclear reactor generate energy?
Nuclear power comes from the energy released in fission processes, like the ones we discussed in nuclear chemistry. The nuclear reactors used for commercial energy production make use of controlled chain reactions of uranium-235. Upon colliding with a neutron, uranium-235 decays spontaneously into two lighter atoms, releasing energy for each atom of uranium that is split. The amount of energy released in the fission process is very large compared to that released from the combustion reactions that we use to obtain energy from fossil fuels. The result is that we can get a lot of energy from a relatively small amount of uranium. In fact, a kilogram of enriched uranium can generate about the same amount of energy as 8 million liters of gasoline.
What is fracking?
Hydraulic fracturing, or fracking, is a technique used to break up rock deep underground in order to release the natural gas trapped inside it. The fluid injected into the rock is generally water-based, but the specific mixtures of chemicals dissolved in that water are generally a closely guarded secret. Using fluids to crack rocks is an old technique dating back over 100 years. But modern techniques trace back to experiments in the 1940s by Floyd Ferris and J.B. Clark, who worked for Staniland Oil and Gas.
Why did Fritz Haber, Germany, win the Nobel Prize for Chemistry?
For the synthesis of ammonia from its elements. Haber was a German chemist, who developed a synthesis of ammonia, NH3, from nitrogen, N2, and hydrogen, H2, along with Karl Bosch, while working at the University of Karlsruhe. Ammonia is critical to many applications, including fertilizers, explosives, and as a feedstock for other chemicals. It is estimated that because of the widespread use of chemical fertilizers, about half of the nitrogen atoms in your body probably pass through the Haber-Bosch process. A significant percentage of our planet's population couldn't exist without this chemical process.
What is the stoichiometry of a reaction?
The stoichiometry of a reaction is closely tied to the idea of the conservation of matter. It tells us the ratio in which the molecules react. Again, using the example at the beginning of this chapter, the reaction stoichiometry 1:2:1. 2 describes the ratio in which methane and oxygen react to form carbon dioxide and water.
What is the difference between mass and weight?
Mass and weight are similar terms, but they have slightly different meanings. Weight tells us how much of something there is by telling us how much gravity is pulling down on it. Mass, on the other hand, just tells us how much of something there is. Independent of the force of gravity on the object.
What happens chemically as stars age?
As stars age, they continually produce helium from hydrogen by fusion. So as time goes by, the amount of helium in a star increases and the amount of hydrogen decreases. In order to keep the fusion reaction going, stars heat up and get brighter as they age. Stars also continually give off a small portion of their mass, which generates solar, or stellar, wind. For our Sun, this is an exceedingly tiny amount of material, so don't worry about it vanishing anytime soon. Finally, stars slowly make elements heavier than helium as they age. This is typically quantified by reporting the ratio of iron to hydrogen in a star. Iron is not the most abundant of the heavier elements present in stars, but it is among the easiest of the heavier elements to detect.
Why did Lars Onsager, United States, win the Nobel Prize for Chemistry?
For the discovery of the reciprocal relations bearing his name, which are fundamental for the thermodynamics of irreversible processes. Onsager received the prize for his brilliant mathematical work that allowed for a theoretical description of irreversible processes. He additionally made a large number of other contributions to physics and chemistry during his career, including developments surrounding the conductivity of solutions and flow of electrolytes, and a solution to the Ising model.
What is the pH of an aqueous solution?
The pH of an aqueous solution provides a description of the concentration of H3O and ions, or water molecules that have accepted an extra proton, in the solution. The pH is calculated as the negative logarithm, base 10, of the activity of H3O and ions in solution. A pH near 7 indicates that the solution is nearly neutral, in the sense that this would be the pH of pure water without any acid or base added. A pH value lower than 7 indicates that the solution is at least somewhat acidic. while a pH above 7 indicates the solution is basic.
What is the freezing point?
Temperature at which liquid and solid phases coexist in equilibrium.
What does that mean?
Superimposable means one object can be placed over another, or less technically, that they're identical. So enantiomers are not identical, but they are mirror images. Take a look at your hands, they are enantiomers. If you put one hand up to a mirror, it looks like your other hand, so they are mirror images. But if you try to put one hand on top of your other, no, not palm to palm. That's cheating. You see, they're not identical, therefore non-superimposable.
What is irreversible reaction?
A reaction in which the products cannot be converted back into the reactants.
What is the Mohs scale of hardness?
Substances, mostly minerals, are ranked by their ability to scratch one another. If one mineral can scratch another mineral, it gets a higher ranking on the Mohs hardness scale. When Friedrich Mohs devised the scale, diamond was the hardness substance known. So it was given a value of 10. Talc, also known as talcum powder, being very soft, has a hardest rating of only 1. Mohs devised this scale to help sort out the private rock collection of an Austrian banker, and later the Archduke's Museum collection. There are more quantitatively accurate measurements of hardness available today. But the simplicity of the Mohs scale keeps it relevant and practical.
What is temperature?
A physical property of matter that describes the average kinetic energy of molecules.
What is a unit cell?
The smallest group of atoms, in a crystal, required to represent the symmetry and overall three-dimensional structure of the crystal.
What makes mercury so dangerous?
Mercury can be absorbed through the skin, making it particularly dangerous to handle. Organometallic mercury compounds, like dimethylmercury, CH3HgCH3, are particularly dangerous and have caused the deaths of a number of laboratory research chemists. Most research on this most toxic of mercury compounds has ceased. Be careful cleaning up that broken thermometer.
What is calorimetry and what is it used for?
Calorimetry involves measuring the amount of energy released during a chemical reaction in the form of heat. This is accomplished using a device called a calorimeter. A calorimeter is a container inside which a chemical reaction can be carried out while thermally insulated from the surroundings. This can even be something as simple as a sealed styrofoam, or coffee cup with a thermometer inserted through the lid, though more sophisticated devices certainly do exist. The temperature change inside the calorimeter can be monitored to determine the amount of energy given off during the chemical reaction, which can then be used to determine the enthalpy change associated with the reaction.
How can I study the effects of acids and bases on sliced fruit getting old and turning brown?
Chemistry principles encountered in this experiment: acids and bases, biochemical/enzymatic reactions, materials you'll need: an apple. Other fruits like bananas, pears, or peaches will also work. 5 clear plastic cups vinegar, lemon juice, baking soda, water, milk of magnesia, measuring cups. The procedure: prepare aqueous solutions of milk of magnesia and baking soda. The amount of water you use isn't particularly important. Feel free to test various concentrations if you'd like. The key aspects are that the baking soda dissolves completely and that the milk of magnesia solution becomes less viscous or thick. Slice your apple, or other fruit of choice, into 5 pieces. If you have decided to test multiple concentrations of baking soda or milk of magnesia solutions, adjust the number of fruit slices accordingly. Label the cups as follows: vinegar, lemon juice, baking soda solution, milk of magnesia solution, and pure water. Place 1 slice of fruit in each cup. Add about degree of a cup of the appropriate solution to each of the cups you have labeled. The fruit should not be completely submerged in the solutions, but make sure each slice of fruit gets completely coated with the solution. The vinegar and lemon juice solutions serve as acidic solutions, of acetic and citric acids, respectively. The baking soda and milk of magnesia solutions serve as basic solutions of sodium bicarbonate and magnesium hydroxide, respectively, while the water serves as a neutral control solution. Write down your observations regarding the physical appearance of each piece of fruit at this time. If you have a camera handy, it might be useful to take a picture of your fruit samples for comparison to the final results. Allow the fruit to sit for 1 day, and then come back and record your observations again. If you took a picture on the first day, you can compare the current appearance of the fruits to your photograph. Apples and fruits turn brown when an enzyme called tyrosinase, refer back to chemistry in the kitchen, carries out a chemical reaction in the presence of oxygen and phenol-containing compounds.
When was nylon discovered?
Nylon 66 was first made by Wallace Carothers, a scientist working at DuPont, R., on February 28, 1935. Dr. Carothers also contributed to the discovery of neoprene, which is used to make suits used for scuba diving.
What is an organometallic complex?
These are molecules with bonds between carbon and a metal. This includes alkali and alkali earth metals, groups 1 and 2 of the periodic table, the transition metals. Groups 3 to 12, including the F block, and sometimes group 13 metals are also included. The bonds between metal and carbon can vary widely in their ionic or covalent character. The bonding between a metal and carbon is mostly ionic in two situations. 1. If the metal is very electropositive, as in groups 1 and 2, or 2. If the carbon group is a stable anion. By being delocalized via resonance as in cyclopentadienyl anion. There are also organometallic molecules with more covalent bonds between the metal atom and the carbon atom. This is usually seen with the transition metals or elements like aluminum. The nature of the metal-carbon bond plays an important role in how organometallic complexes react.
What are hard and soft Lewis acids and bases?
The words hard and soft are commonly used to describe two broad classes of Lewis acids and bases. See chemical reactions. Hard acids and bases typically have small atomic, or ionic radii, high oxidation states, high electronegativity, for bases, and are not very polarizable. Soft acids and bases tend to be the opposite in that they have relatively large atomic or ionic radii, low oxidation states, low electronegativity, and are highly polarizable. As it turns out, hard acids tend to react more rapidly and form stronger bonds with hard bases. And the same is true for soft acids paired with soft bases. This pattern is what makes the theory of hard and soft acids and bases useful for predicting and understanding reactivity in inorganic complexes.
What is an orbital?
A possible arrangement for the density of an electron around the nucleus.
How can a fire be started with a piece of flint?
Almost everyone has seen a movie character start a fire using a piece of flint. But you may wonder how this is possible. Flint is a hard stone that can produce sparks when it is struck against a metal, such as steel. The sharp edge of the flint breaks off a small splinter of steel, which is heated significantly by the friction from the strike of the flint. As this splinter of hot steel reacts with oxygen in the air, a spark is produced. The sparks generated in this way can then ignite a piece of dry wood, paper, or other fuel.
What is the DNA?
An acronym for deoxyribonucleic acid, which is the biomolecule that stores genetic information in organisms.
What is the structure of DNA?
DNA is well known for its double helical structure. Two scientists named James Watson and Francis Crick first discovered this structure in 1953 using data from X-ray diffraction experiments. The two strands of the helix are held together by hydrogen bonding as well as stacking interactions between the aromatic rings of the nitrogenous bases. These strong interactions make the double helical structure very stable. It's also true, however, that the double helical structure has to be temporarily pulled apart when it's time to transcribe the DNA into RNA. This is accomplished by an enzyme called helicase.
What's in self-rising flour that makes it rise?
Baking powder and salt are added to flour to magically transform it into self-rising flour. Yeah, not so magical after all.
If polar bears have black skin and clear fur, why do they look white?
Polar bears appear white for the same reason that a pile of snow looks white: reflection. If there are a lot of surfaces that reflect light, either in the polar bear's fur or a snowdrift, then any light that hits the object will be bounced around many times before coming back toward your eye. Most wavelengths of light are scattered equally well, so you end up with the object looking white. In other words, no wavelengths are absorbed, which would give rise to a color.
What is the greenhouse effect, and how does it affect Earth's temperature?
The greenhouse effect involves the thermal radiation from the Earth's surface being absorbed and re-emitted by gases in the atmosphere, termed greenhouse gases. The re-emitted radiation, much of which is in the infrared region of the spectrum, is sent out in all directions. meaning that some of the energy is sent back down toward the lower atmosphere and the Earth's surface. This results in an overall increase in the surface temperature due to the presence of the greenhouse gases. It should be noted that a certain amount of this greenhouse effect is entirely natural. But the effect can be increased when additional greenhouse gases are introduced into the atmosphere as a result of human activity. As a side note, the name for this effect arises from the fact that greenhouses allow solar radiation to pass through glass and remain inside. In fact, a greenhouse operates on a different principle. The presence of the glass walls in a greenhouse prevent heat from being lost due to convection currents.
How can I make a miniature rocket from a film canister?
Chemistry principles encountered in this experiment: gases and pressure, chemical reactions, materials you'll need. An empty, plastic 35 mm film canister, which are getting more and more rare these days. If you cannot locate one of these, you could try using any other small, lightweight, plastic container with a lid that easily pops on or off. An Alka-Seltzer, R, or other antacid tablet water the procedure. This experiment should be performed outdoors in an open area. Add about 1 teaspoon of water to the film canister, and leave the lid open. Break the antacid tablet in half and get ready to add it to the container. This step requires you to be quick. Drop the broken antacid tablet into the container. Then quickly close the lid and place the canister on the ground with the cap side down. Stand back a good distance, and wait for the rocket to launch. The Alka-Seltzer, R, will react with the water in a reaction that produces carbon dioxide gas. The pressure of this gas will build and build until it exerts a force so great that it will blast the canister off of the cap, shooting the canister into the air. After about 10 to 15 seconds, the canister will launch into the air. Try repeating this experiment using different ratios of Alka-Seltzer, R, to water, or using canisters of different types or sizes. You might also compare different brands of antacid tablets, or different methods for crushing the tablet before you add it to the canister. Compete with your friends to see who can make the rocket that shoots the highest.
How are buffer solutions important in the human body?
One very important buffer solution is human blood. An equilibrium between carbonic acid, H2CO3, and its conjugate base bicarbonate, HCO3. Helps blood to maintain a relatively constant pH of around 7.4. The carbonic acid buffer system is created by carbon dioxide, CO2, dissolved in blood. Carbon dioxide reacts with water, H2O, to form carbonic acid. Since the amount of carbon dioxide in the blood depends on the rate at which you breathe. Your blood pH is influenced by your breathing rate. Your body can actually tell when your blood pH gets too high or too low and adjusts your respiratory rate accordingly.
What is a biochemical pathway?
A biochemical pathway is a cycle of chemical processes that mutually interact to effect some purpose important for biological function.
What is a molecule?
A molecule is a set of atoms held together by chemical bonds. Molecules are the smallest units of a substance that behave as that substance. And separating the atoms of a molecule will change its properties.
Why did Arthur Harden, United Kingdom, win the Nobel Prize for Chemistry?
And Hans Carl August Simon von Euler-Chelpin, Germany, for their investigations on the fermentation of sugar and fermentative enzymes. Harden and Euler-Chelpin were biochemists who independently investigated fermentation processes. Harden discovered that phosphate was required for alcohol fermentation. Euler-Chelpin studied the means by which living cells produced energy by degrading sugar molecules, and the machinery that cells used to perform these reactions.
Why did Dan Shechtman, Israel, win the Nobel Prize for Chemistry?
For the discovery of quasi-crystals. In discovering quasi-crystals, Shechtman initially made some people think he was foolish and just plain wrong. Using a microscope, he found patterns of molecules that appeared to be packed in repeating patterns. But these were patterns that should not be allowed to repeat in a periodic way by simple arguments of geometry. This controversial discovery, and Shechtman's defense of what he observed, led to his being asked to leave his research group at the time of he made the initial discovery. After fighting a long battle, he eventually reached the point where his discovery was recognized. To date, quasi-crystals have not found too many important applications. But they have made scientists rethink the fundamental properties of solid matter, which is certainly a pretty big deal.
What is a buffer?
A solution that tends to resist changes in pH upon addition of an acid or base.
What is a voltage?
A voltage, or potential difference, is the difference in electric potential energy between 2 points. The voltage describes the amount of work that would need to be done per unit charge, to move a charged object between the two positions. A voltage may be present due to a static electric field, to electric current flowing through a magnetic field, or due to magnetic fields that change over time.
What are molecular orbitals?
Molecular orbitals are different from atomic orbitals in that they cover several atoms and possibly even a whole molecule. While atomic orbitals originate from a single atom, molecular orbitals are formed from combinations of the atomic orbitals. Because they allow electrons to occupy the space between the atoms in a molecule, they can provide a very useful description of chemical bonds holding atoms together.
How did pharmaceutical science get started?
Paracelsus is credited with being the first person to use chemicals in medicine. Before Paracelsus, people believed that illness and disease were caused by an imbalance in the patient. Hippocrates thought it was an imbalance of the 4 humors: blood, phlegm, black bile, and yellow bile. And Galen furthered these ideas by assigning a symptom to an imbalance of each of Hippocrates' humors. These theories supported the use of medical techniques like bloodletting. Paracelsus believed that illness was the result of something from the outside world attacking inside one's body, and that some of the illnesses could be cured by chemicals. He is also known for proposing the basis of toxicology, namely that dosage was critical to whether a substance was poisonous or not.
How do planes stay in the air?
Airplanes are very heavy, so the force required to balance gravity and keep them in the air must be large. The engines propel the airplane forward, but we need to understand what gives the upward push or lift necessary to keep the plane in the air. This lift comes from the shape of the wings, which are typically curved on the top and flat on the bottom. This design requires air to flow more rapidly over the top of the wings than over the bottom, which creates a lower air pressure above the wing than below. The lower air pressure above the wing is what lifts the plane off the ground and keeps it in the air. This is commonly referred to as the Bernoulli principle. If you blow across the top of a sheet of paper, you will see it lift into the air for the same reason.
What is an electrophile?
A species that is attracted to electron-rich atoms or molecules.
How was the modern periodic table developed?
A French geologist named Alexandre Biguier de Chancourtois is actually the first on record to list all of the elements in order of increasing atomic mass. His first version contained 62 elements and they were placed in columns that wrapped around a cylinder. However, there were a variety of issues with this first attempt that were later improved upon. Newlands made the next significant advance, publishing the elements in columns of those with similar properties, which brought the description close to the version chemists use today. The modern version of the periodic table was proposed by a Russian scientist named Dmitry Mendeleev in 1869. His table was the first to lay out the elements in order of increasing atomic mass in columns of elements with similar reactivity. Elements on the table appeared periodically, essentially in accordance with the law of octaves, hence the name the periodic table. Mendeleev's table had to include some blank spaces so that the elements were each in the proper column according to reactivity. As more elements were discovered, the blank spaces in the table were eventually filled in, validating Mendeleev's table.
What are the different phases of matter?
There are three phases, or states, of matter that you come across every day: solids, liquids, and gases. There is a fourth phase of matter, plasma, which is only naturally found in stars and elsewhere in outer space. The distinctions between the first three phases are usually made using bulk properties. Solids have a defined shape and volume, while liquids easily change their shape but not their volume. Gases have neither a defined shape nor volume.
What is work?
A force acting over a distance, such as a person lifting a box.
What do atomic orbitals look like?
There are three main shapes of orbitals relevant to most of chemistry, and these are referred to as s, p, and d orbitals. The designations s, p, and d are abbreviations for sharp, principal, diffuse, and fundamental, which have historical significance describing results of early experiments to probe the electronic structure of atoms. You can see what these orbitals look like in the graphic on the preceding page. The shapes of these orbitals are determined by their orbital angular momentum, which is a property that describes the motion of the electron around a nucleus.
What is gravimetric analysis?
Gravimetric analysis refers to any method for quantifying the amount of an analyte based on mass. For analytes dissolved in a solution, this may require first reacting the Analyte with another species to cause it to precipitate out of the solution. The solid product can then be filtered and weighed. And the mass of the analyte initially dissolved in the solution can be determined. Other situations may require different methods of preparing the analyte in an appropriate form for weighing. But the general idea is always that the composition of the weighed species is known. So it's possible to figure out the mass of the analyte originally present.
How far away can one molecule feel another?
Molecules feel one another through the intermolecular forces they exert on one another. These typically span lengths that are a little longer than the length of chemical bonds, or something in the neighborhood of 5 × 10 to 10 meters.
What is a nucleotide?
Nucleotides are one of the basic units for another class of biomolecules, the ones that join together to form your DNA and RNA. The long names for these are deoxyribonucleic acid and ribonucleic acid. DNA and RNA are the macromolecules that store the genetic information in your body. A nucleotide consists of 3 parts, a nitrogenous base, a sugar, and a phosphate group. The identity of the nitrogenous base determines which letter in the genetic code is associated with the nucleotide, while the type of sugar determines whether the nucleotide is a ribonucleotide or a deoxyribonucleotide, which essentially just tells us whether it's going to be a part of RNA or a part of DNA.
What is an isotope?
Isotopes are atoms with the same number of protons and electrons, but with different numbers of neutrons. Since the numbers of protons and electrons effectively determine the reactivity of an atom, isotopes have the same basic chemical properties and are the same element. They have different masses, though, since they have different numbers of neutrons. The various isotopes of an element are usually present in relatively fixed ratios throughout nature. But in some cases the ratio can depend on the environment or molecule in which they are found. For example, the element carbon most commonly exists with 6 protons, 6 neutrons, and 6 electrons, referred to as carbon-12, the total number of particles in the nucleus. A small fraction, however, have 6 protons, 7 neutrons, and 6 electrons, carbon-13. Roughly 99% of carbon atoms have 6 neutrons, but most of the remaining 1% have 7 neutrons.
What is amorphous?
A solid without a repeating, ordered structure.
What is ink made of?
Inks can be very complicated mixtures, but two key ingredients are the pigment used to color the ink and the solvent used to dissolve, or at least suspend, the pigment particles. While modern inks come in every color imaginable for a host of different pen types, historically inks fell into one of two major categories. The first is carbon-based inks. Residues from burning wood or oil, like soot, were used as coloring in these inks, which were suspended in the sap of the acacia tree, known today as gum arabic. The other type of ink used historically is called iron gall. The iron was usually added in the form of iron sulfate, Fe2 plus SO4. Gall refers to gallotannic acid that was extracted from growths, or galls, on oak trees. Iron gall ink slowly darkens as the iron ions undergo oxidation from Fe2 plus to Fe3 plus. The acidity of the ink solution can cause damage to the paper it is used on. So preservation of historical documents that were written with iron gall ink is challenging.
What is rayon?
You probably know what rayon fabric looks or feels like. The best Hawaiian shirts and much of 1980s fashion were made of it. What's fascinating about rayon is that it is not really a synthetic or a natural fiber. Rayon is a chemically modified cellulose polymer, first prepared in the 1850s. While there have been a number of ways of preparing this artificial silk, the viscose method led to the first commercial production of rayon. This method treated cellulose with a combination of sodium hydroxide and carbon disulfide as indicated below.
What is radio astronomy?
Radio astronomers study what's going on in outer space by using radio waves, as opposed to telescopes, which use light in the visible region of the spectrum. This approach has some distinct advantages, perhaps the most obvious being that radio astronomers can work at any time of the day, while astronomers who rely on light telescopes can only work at night. Radio astronomy relies on monitoring weak radio wave signals coming in from outer space, and knowing how to interpret these signals to draw conclusions about the locations of celestial bodies and events that have taken place far, far away.
Why do Diet Coke, R, and Mentos, R, fizz like that?
In Diet Coke, R, and all soda, there are a lot of CO2 molecules trapped in solution. The slow release of CO2 from solution is what normally makes the calm bubbling in soda.
What are degenerate orbitals?
Atomic or molecular orbitals of equal energy.
What is the philosopher's stone?
The philosopher's stone was an object of legend among alchemists. It was believed that the philosopher's stone possessed the power to make gold from other cheap metals. It has also been said to serve as the elixir of life, which was sought by many alchemists. Of course, such a stone has never been discovered, at least not outside of Hogwarts.
What are chromosomes?
Chromosomes are a bundle of DNA and proteins packaged together. They are how your DNA is stored in your cells when it isn't being read by any enzymes. Each chromosome contains a large number of genes. Humans each have 46 chromosomes, all of which are present in each cell in the body. Chromosomes need to be unpacked by enzymes before their DNA can be read by RNA polymerase or other enzymes.
What is a physical change?
A physical change is a change involving the macroscopic properties of a substance without any accompanying change in chemical composition. A few examples of physical changes would be evaporating, melting, cutting, slicing, breaking, and grinding. The key similarity is that none of these processes involve changing the chemical makeup of the substance.